Okay, so I'm just demonstrating high voltage, current, and the effect of plasma on a magnetic field. So let's go ahead. Right now, my full heart intention is I'm going to be using DC voltages for DC uh, voltage for making plasma blimps because it's easier to control with diodes and electronics. But AC, it has backflow. It'll flow back on you, and you can't make it move specifically to how you want it to, and you don't know where the positive ions are. They're pretty much all mixed together. So yeah, DC is definitely the area where I want to go with this, but for right now we have AC, and it allows a lot of current flow. So let's go ahead and look at the plasma, unregulated, I guess you could say. So here we go. So yeah. Anyways, that's my AC current. Go ahead and shut down the power supply. Go ahead and de-energize the probes. Okay. No discharge. Alright, so here's a magnet. Now, even at a distance, the magnet's going to be affected by the current. The plasma is going to be affected by the magnet. See, you can see the plasma is getting shorter. It's definitely not going as far as it was. As soon as it starts getting close to that magnetic field, it starts breaking off. Go ahead and turn off the power supply, discharge, get the magnet really close. Now, the magnet is actually 3 centimeters away from the probe, the positive probe, and I'm going to be pulling up on it. Okay, now I'm moving at it from the side, millimeter. Actually, that plasma flame is actually trying to go around the magnet. I don't know if you can see that or not. So anyways, that's 1 millimeter from the side of the magnet. Now, I'm going to go ahead and put the probe, discharge, okay. I'm going to put the probe around the edge of the magnet. Alright. And I'm going to keep that probe at about 3 centimeters is what I want. 3 centimeters away from the corner, away from the edge of that magnet. Because what I'm going to be demonstrating here is a change in the way the plasma is moving at the corner of the magnet. Alright, so I'm going to go ahead and use that. Alright, so I got this at, okay, it's at about 10 millimeters away from the corner. But anyways, it's in the proximity of that magnetic field. So you see that? Let's look at it from the side here. It's pretty much a sideways tornado, isn't it? Okay, so that's it at the corner of the magnet. Discharge. Now the probes are getting really hot. Dang. Alright, now I'm putting the probes in the middle. So now it's at probably 15 millimeters away from that center. I want a little bit closer than that. Alright, there we go. Now the probe is, well, it is about 3 millimeters from the top surface of the ring magnet. Alright, let's go ahead and see what that does. 3 millimeters away from that top surface. Come on. So, I don't know if you can even see that or what, but it's a tornado inside of there. The plasma is swirling inside of the magnet. Pretty much, that's typical for what you'll see normally. So yeah, the current is definitely being affected by this magnet, so thus the magnet is being affected by the plasma, but there isn't a lot of current. The current is really low in the milliamps, and in order to get the current up high enough that you can actually play with it, it's going to need to be very dangerous. It's going to need to be like at least 10 amps before you're going to see something substantial, and you're going to be needing tens of thousands of volts. All right, so this is a tube that I'm going to be using. In order to make this tube work, it's going to need to be 100,000 volts, and then it's going to need to be so many amps. But what I'm going to do is a magic trick. So I'm going to use something like a Van de Graaff, a capacitance charge discharge, and I'm going to discharge 100,000 volts. But the actual current carrying voltage is going to be much lower, like maybe 1500 volts, very low voltage, and they're both going to be DC. So the high voltage discharge is not going to, the high current is not going to be discharging to the high voltage discharge. They're going to be two different separate banks, and the high voltage discharge will shoot, and then the high current will shoot right behind that, flowing through that um, streamer, just like a real lightning bolt does. And then I want to get the current up high enough in the amps range, in serious amps range, uh, before I even start expecting a good enough magnetic field that I'm going to be able to pull on or whatnot. So that's the type of power that you're going to need before I'm going to see a project that really shows an example of how you're going to be able to make flight with a plasma blimp. All right, so that's the test experiment project.